I spent a lot of 2018 designing, refining, and manufacturing this tube bender. If you follow me on Instagram or in the YouTube videos, you might have seen me make references to this. You might have seen pictures. It's on my web store. But this video is going to explain who it's for and why I designed it the way that I did. Let's get into it. This bender is specifically for bicycle frame building. You could possibly use it for other tasks, but all the design considerations were driven by specific applications of bending thin wall chromoly steel and titanium tubes primarily. And so when you're bending that kind of tubing, there's different considerations that go into it than if you were bending the roll cage of a race car as a hobbyist. There's a lot of tube benders marketed toward that sort of market, or if you were building a bumper for your Jeep or your off-road truck or something, that's heavier wall tubing. The fine detail of the bends is less critical. People aren't scrutinizing it as closely. When you make a beautiful bike that you're selling for thousands of dollars with a high gloss paint job, you don't want to see little marks from where the clamp mechanism was holding onto the tube. You don't want to see rippling. You don't want to see kinking. You don't want the tube to draw into the dot. There's a different set of considerations. This doesn't require as much muscle as a bender that's driven by hydraulics that can bend 120 thousandths wall tubing, really heavy stuff, but this has a different set of considerations that go into it, and so I made it specifically for building bike frames. So at first I was designing something that would do seat tubes for a mountain bike, but I've expanded it and I have dies for seat stays and chain stays, round tubing in 5/8 inch, 3/4, 7/8 inch, and then main tubes that go all the way up to 1 3/8, and I've even made dies that go up to 1 5/8, and I'm testing with those and trying to determine whether or not that's really a sustainable offering, if those dies would wear out, and what kind of success rate people would have. One of the big drivers for this project was that I've always had a small shop space. And when you have a small shop space and you have a limited budget, right? Everyone's working within a budget. This isn't a tool for Trek or Specialized or some huge production factory. They have more specialized benders and they cost a fortune and they're huge. But if you have a small space, if you're working in your basement, in your garage, in a small rented space, you need something that is something you can move around, something that's small enough footprint. This right here, I bolted it onto my Bridgeport because that's a convenient spot in my shop, but if I needed to, I could bolt it to any old thing like a card table, because all of the force of the bend happens between these bending arms. There's a lead screw here, there's a bronze nut at the end of the lead screw, and there's bearings down here. And so when you tighten this, there's a lot of force that's contained in the tool. But unlike with a manual bender, the anchor point doesn't need to be heavy. So when you have a manual bender, right, you'd have a long bending lever, and then you would bolt it to something heavy duty, such as this machine, and then you would lift on that lever, and you would bend the tube. And so if you didn't have it mounted to something heavy, it would just, you wouldn't be able to bend it. The thing would move or lift up your table. And so as you get into bigger tubes, like main tubes of a bicycle, you can't hardly get a heavy enough anchor point. And so if you wanted to bend the seat tube of a mountain bike or a down tube or something, you would need to build some very rigid, post and bolt it into the concrete of your shop floor, or you need to bolt it to like a 5,000-pound machine. And this, all the force is self-contained. You can mount it to whatever, and you can make a quick disconnect mount, and you could pick the thing up and you could put it in a drawer, hang it on a shelf, hook it on the wall, whatever, to get it out of the way if your shop space is so limited that every time you finish using it you need to put it away. Another thing is that the dies are all interchangeable and they're easy to change in and out, so here's a video of me demonstrating that from a couple weeks ago. I need to switch the bending die from this size to this size, which is really easy to do. It really helps to have a T-handle 6mm Allen wrench like this. It's just 2 long screws that pass through this part of the tool. So this piece drops out from below. Go ahead and put another one in. There's actually locating pins on this that made up to holes in this. So as soon as I set it on those pins, it's located, and I just have to run the screws back in again. And I'm done. So most of the dies are single dies where along the center line you have a half round for whatever particular diameter of tubing it supports. However, for 5/8 and 3/4 inch tubing, I have double dies. So if you're doing a matched pair of seat stays or chain stays in those diameters, you can put them side by side and you get a 2-for-1. You can bend side by side, and it helps you get repeatability in your bends, and it also should save some time too. And now down here you have a phase arm. So if you have S-bend stays, or maybe you're doing a down tube and you do a bend for like a fork crown clearance and another bend at the bottom bracket or something wacky, if you want those bends to lie in the same plane on the tube, then you want to phase the tubes. And so you want, both bends to lie flat in there. And when you're loading your tube, let's pretend this already had a bend in it, I would load it in from below, and now I would spin the tube like this, and I would sweep it around until it fit against the V-notch here. And so just swing it down, and if it's not in phase, then it's going to be swung out to one side or the other. And then I have a double V-notch here on the back side for if you're doing the double stay bending. So I'm going to demonstrate loading a tube. First, let me show you this. This is the whole clamp block assembly. So this clamps the tubing against the die, and because of the whole contraption going on here, it makes it really easy. So if you have different diameter tubing, then this piece here is interchangeable. I use these little hair ties so that everything would be self-contained. You're not gonna drop that. You don't need to hold on to it. It's in there. And then as you tighten the screw, it puts more pressure on there. I have a hard steel thread insert here to keep this aluminum from getting chewed up by the threads and the clamping pressure. And so when I go to load a tube, I grab the tube and I load it in from below. Then I grab my clamp block assembly. I hold it there. It's easy to hold with one hand. And I grab the pin. Now I get this finger tight, and I grab my wrench. Now it's good and tight. It's loaded in there. Now I want to load in my follow bar, and this is what allows you to get the real smooth bend, because you have all this surface area, a real smooth texture on the die, and it's the exact geometry you want. So there's no space for the tube to buckle into. There's no pressure points. If this had a rough surface texture, or if it wasn't machined very accurately, there would be a visible texture on the die, and that would transfer onto the tube. You would be able to see it on the tube. And so it needs to be a smooth die from the start. You load it in from above, and now there's this roller, and there's pressure that I can apply to the roller right here with a hex. There's again, it's a 3/4 hex, which is like exactly 19 millimeters. So if you have metric wrenches, it's incredibly close. You can use a 19 millimeter wrench also, and you don't usually actually need to put preload on this, but I wanted a screw to be here so that it would be adjustable. And one of the main reasons is that when you go to remove the tube, if you can't back off this screw any, the spring tension on this makes it really hard to pull that follow bar out of there. And so just by making it possible to back off that roller a little bit at the end of the bend, your whole life is a lot easier. So I'll just run it up until it's snug. And we start the bend down here. You see there's graduations here for degrees of bend. So that is the 0 degree tick mark, and it's referenced off of this face on this arm. And as you turn the screw, you're lifting this arm. It's pivoting about this point, right? And so if you lift it up, it drives the bend. And here's another clip of me. This is me driving a bend, and I like to perform it, with a 1/2 inch drill. It drives really nice. So with the tube loaded up, I use an adapter so that I can use a ratchet socket, and for a 3/4 on the bottom of the lead screw here, I like to use a 1/2 inch cordless drill in low range with the slip clutch turned off, and I like to use this as preferred to something like this 1/2 inch drill here, because this doesn't spin, this spins down slowly and you don't have as much control over this. I also think it could be a safety concern. It certainly has more torque. I've found that a quality 1/2 inch cordless drill in low range has enough oomph to drive the bend. So I got everything loaded in here and locked down, and here we go. Then I like to put it in high range to back it off a little bit faster. You just want to keep your fingers out of there because there's a lot of leverage with the screw. And there we are. Now I can back off this nut. Pretty easily remove my follow bar, and I can remove the tubing. Comes out real nice. Gets a little bit shiny on the side here, but you can't feel that, you wouldn't see that through paint. Here's some example bends that I have. This one is 1¼ chromoly steel by 35 thousandths wall thickness, bent to 6 3/4 inch centerline radius. That's the medium radius that I have. Bends really smooth. You can't see where the clamp came in. It's really, really slick. This one's titanium. Again, it's 1¼ outside diameter, roughly 0.35 wall. And I bent this one to the 9-inch bend radius. Very smooth. You don't really see anything on the tube, any clues that it was bent by any sort of machine, really. This one also titanium, 1 3/8, 6 3/4 inch centerline radius. I bent this one, I think, a little bit further, more degree of bend. And I think it says 0.36 wall on this one. So this one is 4130 steel, 0.28 wall, 1 3/8, and this was bent to the 6 3/4 centerline radius with quite a bit of bend. And so what you'll see with the thinner wall tubing is more flattening on the outside of the bend here. And so this is pretty extreme. 0.28 wall is thinner than a lot of people would build into a bike frame for a bent tube anyhow, but I wanted to push the limits and test it a little bit. If you do 0.35 wall, it's much less pronounced. You don't really see it as much. But again, overall it's a very smooth bend. The only way to really avoid this sort of flattening is to have internal support, which is a whole other can of worms, and the tube bender is more complicated, or else you're fussing around with filling stuff. So even when you get thin, you can get away without internal support. So the way you see it set up here is I have this thing, I call it a mount tube. It's an 1 3/4 steel square tube, and it just, basically the design of the tool is such that you wouldn't set this down on a flat table. You need to be able to access underneath it for the tube and for the phase arm. And so by putting it on this, you can extend it a little bit over the edge of something. And so it ships with one of these square tubes. You can clamp this into a vise. You can bolt this down onto a table. You can bolt it to a machine. You can weld a plate onto the end of it, and you can screw it into the wall. You can make some sophisticated and totally badass like quick disconnect. Everybody's shop is going to be a little bit different. Where you can fit it in is going to be a little bit different, and down the road I might offer like a one size fits all or a couple sizes fits all offerings, but for now it's just going to ship with this square tube, and anybody who can make a bike frame is enough of a fabricator that they can figure out where to drill the holes and how to weld it to what they want so that it best suits their needs in their shop. Along with the dies being interchangeable and easy to interchange, this supports 3 bending radii. There's 9-inch, 6 3/4, and 4.5. So if you need really tight radius bends for stays, you can get those, and if you want more of a swoopy gradual bend, you can get that too. And of course, for some of the real large diameter tubing, it's not even possible to bend at the tightest radius, and so that's why, part of why it needs to have that. I made it real easy to switch the radius. So this is a threaded cap. You don't need any tools, and you just back out the pin. And so it looks like this. This side is fixed on here. It can't come loose without a tool. And now I just line up the holes. I thread it together, and now I'm on this 6 3/4 centerline radius, which matches this die. As you're changing the bending radius, you do need to keep in mind that it corresponds with your bending die, because, for instance, a 7/8 diameter bending die can come in 3 different radii, and so you just need to make sure that you're on track for the right one and that your pin is in the right hole. There's a lot of bending dies to choose from. I'm trying to keep as many of them in stock and ready to ship as possible, and to have a reasonable lead time for anything that runs out of stock, so that as a customer you can get what you need to make the bikes you need to, in a reasonable time frame. So right now I mostly have fractional inch offerings, so 5/8 of an inch up to 1 3/8, and I'll be expanding that even a little bit more. But in addition to fractional inch sizes, I want to offer 27.2 millimeters, 30.9, 31.6 for seat posts. That's a common question I've been getting, and I want to supply those, and so I'll be offering those. And then I might be also offering in the future in a package that you can buy to put on this that will allow you to bend traditional tapered steel fork blades. So I'm not 100% sure they'll offer that. I haven't worked out all the details, but I'm pretty sure that this bending apparatus would do that with the addition of a couple special pieces. And so that's something you might see in the next year, that you'll just be plug and play with this exact tool. So when you take into consideration all the different dies that I already offer and the ones that I'm definitely going to offer, you'll be able to bend seat stays, chain stays, a lot of handlebar material. You can do main tubes, including like seat tubes, top tubes for a step-through frame. You could do down tubes for a mountain bike frame where you're making fork crown clearance. There are a lot of applications where these bending radii for these diameter of tubing would be really useful. And in the bike frame, you always want those smooth bends, and you always want to be able to get that repeatability. So there's a lot of other benders out there. There's a Diacro, does a nice stay bend. There's the Anvil bender. There's different like Swag Off-Road and JD Squared. There's different tube bender offerings out there, and I think that this is a really valuable package to the frame builder because it can do all of that in one. And so the footprint is small, and the mechanism by which it does the bends I think is elegant. There's a bronze nut up here, and that is a wear item, right? As there's friction here, and so I designed this nut to be machined in 2 operations on my mill, and it's a small piece of bronze. And so the idea is that if this ever should wear out for a customer of mine, which I think it has a long service life, it's a hard slippery bronze, but if it ever wears out, I'll have those in stock and ready to ship for a very reasonable price for people. Down here at the bottom there's a needle thrust bearing and 2 hardened washers, and those from McMaster-Carr are a couple dollars, and I'll have the part number for that readily available for anyone in case they ever have issues with that or they want to overhaul the tool. There's a bronze sleeve bearing down here also for the very light radial load. I can't imagine that would ever wear out. Like, I just can't imagine that. But if it did, you can press it out and you can replace it with a different piece, and those are like $1 from McMaster-Carr. And here, this threaded rod, this is bonded in with Loctite to the end of the shaft, and so this is simple enough. This is a 1/2" 20 thread. This would be simple enough for anyone to replace on their own, but if they're having any trouble or questions with it, I could sell a replacement lead screw. So anyway, the point is that this is all pretty simple and pretty affordable stuff, and I'm going to stand by and service it if anybody needs help. If they happen to do so many bends that parts of it are wearing out, I want to help people make the most of their tool. It's not a disposable item. It's something that's meant for a lot of use. I realize that a lot of frame builders are not high volume production builders, and so they have different sort of driving considerations of what they need to get done the job. You know, if you had an unlimited budget, you would build it differently. If you had unlimited shop space, you would do it differently. If you were, you know, building bikes exactly the same way every time and you didn't need the flexibility, you would build it differently. But this is designed specifically for the sort of custom small you know, boutique builder who's making a bespoke bicycle, right, a handmade bicycle. I tried to put in all the experiences that I had doing that and all of the stuff that I've seen and being a huge frame building nerd for years and years into the design of this, so that it meets the most salient needs the best. It doesn't do everything. You're not going to use this on the, you know, the side projects that you have to bend some really heavy pipe or something. I mean, maybe you can, but like you might damage it. You know, it's meant specifically for bike frame building, and for that, I think it excels. So the base price for the tool gets you this whole apparatus as you see it, basically, without the tube, right? And so you get the bend phasing arm, and it comes with one bending die and one follow bar and one clamp block, so that you can do one diameter of tube to one radius. And then each additional setup comes with a bending die and a clamp block and a follow bar, unless of course you're trying to bend the same diameter tube to a different radius. Then you would be paying a little bit less because you only need the bending die. And so the prices and all that stuff is on the website rather than in the video, in case any of that changes. I have one place to update, but if there's anything that you don't see on there, any questions you have, just send me a message. If there's something that you would like to see that I'm not offering, just send me a message and ask me about it, and maybe it's something that we could offer if we're not offering right now. When you're trying to bend tubes and you don't have the benders you need, but the bike you're trying to build requires those bends, I've been there, I think most of us have been there, it's really frustrating. And so when I designed this, I wanted to put a lot of thought into how to make this work and how to make it not frustrating. I wanted this whole thing to be a joy to use, a joy to look at, to make just really repeatable and consistent bends that you're not fighting your tooling. And so if that sounds like something that you could really use in your shop and in your process so you can make your best work for yourself or for your customers, I think you should consider giving me a call and buying this tool. Thanks for watching.